In this example, we want to determine any relative extrema for the function 2x to the third minus 3x squared minus 12x plus 10 and throw it onto a graph. So the first thing we want to do is we want to use that first derivative test. So we're going to take the first derivative. We're going to get 3 times 2 is 6x, 3 minus 1 is squared. 3 times 2 again is going to be 6x, and this is 2 minus 1, so we just get 1. Minus 12. 10 is a constant, so that's going to drop out. So there's our first derivative. Now we want to locate any sort of critical values. In order to locate critical values, we want to take our derivative and set it equal to 0, because we want to know where do we have some horizontal tangent line, so where is that derivative equal to 0. So we're going to go ahead and set that derivative, 6x squared minus 6x minus 12, equal to 0. So now we just have a quadratic, so we want to solve this and solve for x here. And in order to do that first, we have to factor out a 6, because I have a 6, 6, and 12. So I'm going to factor out a 6. X squared, so I took out a 6 from there, took out a 6 from there, so I'm just left with minus x here. Took out 6 from 12, so 12 divided by 6 is 2, so that's going to be minus 2 equal to 0. We want to factor this trinomial. So I want two numbers that multiply to negative 2 and also add up to negative 1. Nothing too complicated there. It's going to be negative 2 times 1. Negative 2 times 1 is negative 2. Negative 2 plus 1 is negative 1. So I have 6, and the 6 is just a constant, so that pretty much just disappears. But I'll just write it down for now. So we have 6 times x minus 2 times x plus 1 equal to 0. Negative 2 times 1 is negative 2. Negative 2 plus 1 is negative 1. So there we go. Set both factors equal to 0. X minus 2, x plus 1. Like I said, just 6 is a constant, so we don't even have to worry about that at this point. So we have x equal to 2. Add the 2 over. And we subtract 1 over. So we get x equal to negative 1. So at these x values, we have something going on. We have a horizontal tangent there, meaning that at the x value of negative 1, it's flattening out. Now it could mean that it's decreasing to negative 1 and then it's changing to increasing, or maybe it's decreasing and then just flattening out and then also decreasing. Like something's happening at negative 1, something's happening at positive 2. So we have to figure that out. That's our next step. Okay, let me erase my factoring here. So we're going to create some intervals, and since we have these two critical values of negative 1 and 2, I want to create the interval negative infinity to negative 1, and then I want to go from negative 1 to 2, and then I want to go from 2 to infinity. So the reason I'm doing that is because at negative 1, it's flattening out, so I want to know what is happening to the left of negative 1. Is it increasing into negative 1, or is it decreasing into negative 1? And then I want to know what's happening from negative 1 to 2. How is it connecting? Was it decreasing and then increasing to 2, or was it increasing and then decreasing to 2? Well, what is happening from negative 1 to 2? And then we want to know what's happening on the other side of 2 to infinity. So in order to do that now, we are going to use that first derivative test where we plug in some x values into each of these intervals into the derivative. So I'm going to take f prime of any value in this interval will be perfectly fine, but why make it tough on yourself? Let's just take an easier value like negative 2. Let's plug it into the first derivative. In this interval, whenever you have an interval with 0, and 0 is completely fair game, use 0. Don't make your life any more complicated than it needs to be. And then here, 2 to infinity, let's just go with 3. So I'm plugging in negative 2 into my derivative. Here was the derivative. So I'm going to plug in negative 2. So it's going to be 6 times negative 2 squared minus 6 times negative 2 minus 12. I don't want to mess up my mental math here, so I have my calculator ready to go. So I'm going to do 6 times negative 2 squared minus 6 times negative 2 minus 12. That's going to be positive 24. And it's not even necessary that we really care what the value was, so I probably didn't even need to actually figure out the value. All we really care about is the sign, right? Like, we just want to know if it's positive or negative. And probably could have just figured that out because it's going to be 6 times a negative 2 squared. It's going to be both positive and then negative and negative, positive. So bigger positive minus smaller positive minus a very small number compared to this. Like this is going to be positive. Like, so I probably didn't even need to get an actual value, but just to play it safe, I'm just going to put these in my calculator. But that's a positive. That value is greater than 0. So since in this interval, the derivative was positive, that means it is going to be increasing on this interval. So from negative infinity to negative 1, it is going to be increasing. So now we do that same thing for the rest of the intervals. So I'm going to do 6 times 0 squared minus 6 times 0 minus 12. And that's actually pretty easy to do. 0. So it's going to be 6 times 0 squared. 0 squared is 0. 0 times 6 is 0. Minus 6 times 0 is 0. Minus 12. 0 minus 12 is a negative 12. So that's negative. So that's decreasing. So the f prime of x in this interval is less than 0. So that means it's going to be decreasing on this interval. So think about that visually. Increasing, decreasing. So then now we get to this x value of 2, and then we're wondering what's going on there. I'm going to just move myself to the top left corner here. And then on this last one, we want to plug in 3. So 6, 3 squared minus 6 times 3 minus 12. So let's just play it safe. And once you develop a level of comfort, like you could look at that and just kind of know, like, all right, I'm going to have 6 times 3 squared, which is going to be 6 times 9, which is 54. Minus 18 minus 12, and like you pretty much get a good idea of just from looking at those numbers that is going to be positive, but never hurts to just plug things in your calculator just to play it safe while you're starting off. And that means our derivative is greater than 0, so that's going to be increasing on this interval. So we want to determine any relative extrema. We know that at the x value of negative 1, what's happening there is it's increasing, and then it's decreasing at negative 1. So negative 1 is going to be a relative maximum. And we're going to throw this onto the graph in a second here. And then at 2, it's decreasing into 2, and then increasing, so it's going to be relative minimum. So we want to get the ordered pairs that correspond to those points. So I'm going to do f of negative 1 and f of 2. I'm plugging into the original function, f of negative 1, f of 2, into the original function, so that way I get the y values that correspond to those points. So let me just do that real quick. 2 times negative 1 to the third minus 3 negative 1 squared minus 12 times negative 1 plus 10. So the y value there is going to be 17. So this ordered pair is negative 1, 17. F of 2, 2 times 2 to the third minus 3 times 2 squared minus 12 times 2 plus 10. That's going to be negative 10. So this ordered pair is going to be 2, negative 10. So at negative 1, 17, I'm going to go off my graph a little bit here. That's fine. And then 2, negative 10 down here. So what we decided was on this side of negative 1, it was increasing. So it's doing something like this. Now here's the part where, depending on if you're just learning this on your own or if you're in a class or something, depending on your instruction, some teachers are just like, all right, we know this is increasing on this side, so just draw a line increasing into it. And some people will be like, well, let's get a couple x values on this side of x equal to negative 1. So then that way you know, is it like doing this? Is it coming in a little bit steeper? Like, what is it doing? I'll just grab one x value just to get an idea. Like, am I coming out from all over here? Is it like, what is the trajectory here going up to that negative 1? So I'll just take like f of negative 6. Like, I don't know, just kind of looking at a point. So I'm just do f of negative 6 just to get an idea of like, where am I coming from here? So I'm going to do 2, negative 6 to the third. And if you have time, like you could obviously get a whole bunch of points to get an extremely precise looking graph. But just for the sake of time, I typically will just have my students just, so negative 458, wow. So at negative 6, it's at negative 458, so this is going to be pretty steep. This is going to be pretty steep coming in. So it's like all the way down here. Negative 458 was the Y value I got back, so it's going to be pretty steep. So just it gives me an idea that I'm not coming in from here. It's going to be pretty steep. I should probably even go a little bit closer like that. So it's coming in here, and then this way I got to go to my positive 2, and then we decided this is increasing, so it's going to go back up, and you can do the same thing. So I'm just going to reuse, I'm going to use positive 6 this time, so I'm just going to go back and change around my values to positive 6. That's positive 262, so that's going to be pretty steep also on the other side of this. So there it is. There is my graph, and we decided that negative 117 was a relative minimum. Oh, I'm sorry, not a minimum, maximum. Negative 117 was a maximum. To negative 10 was a relative minimum, because it bottoms out. So relative max right here. And then a relative minimum right here. And there it is. Quite a process. But there it is.